Dear Professor Levashenko, you're with us?
Yes, I'm here.
Okay, wonderful. And Professor Uljagas? Uljagas?
Yes, I am here. I'm here.
Oh,
Can you hear
okay,
me?
thank you. So we can begin then. Please start the recording.
Recording.
Okay.
Started.
Dear members of dissertation councils, dear colleagues, so we begin. According to the approved composition of the dissertation council at SD University, the permanent composition of the dissertation council for the defense of dissertations for the degree of Doctor of Philosophy PhD in Educational Program 8D06102 Computer Science has been approved in the number of 4 members, which are Bogdanchik Andrei, the chairman, associate professor, vice director for strategic development and digitalization at SDU. Then Professor Vitaly Levashenko, member of the dissertation council. He is assistant professor in the Department of Informatics, University of Jelina, Slovakia. Then Professor Al-Hadithi Mohammed Ala Fathil, who is assistant professor at SD University, member of the dissertation council. And Professor Dana Utibayeva, scientific secretary of dissertation council. She is assistant professor at SD University, scientific secretary of the dissertation council. At the meeting of the Dissertation Council for the Defense of Dissertations for the degree of Doctor of Philosophy PhD in Educational Program 8D06102 Computer Science regarding the review and acceptance of Sadyk Ualikhan Sadyk dissertation for the defense, the permanent members of the council appointed 3 temporary members of the Dissertation Council, which are Professor Jandos Dosbaev, PhD senior researcher of the Zholdazbekov Institute of Mechanics and Engineering. Then Professor Dauren Jeksibay, who is a PhD acting associate professor, senior lecturer at the Electronics and Astrophysics in Department of Al-Farabi, Kazakh National University. Then Professor Zolgaz Seydaliyeva, who is a PhD leading researcher at Satpayev University. So currently we have all 7 members present of our council. And so we continue. The quorum for holding the council meeting is met. Out of 7 members, all 7 are present, which is more than 2/3 of the total composition. Among them, considering the nature of the dissertation under review, we invited 3 extra members, so meeting the legitimate, deemed the legitimate. It's proposed to begin the work of the dissertation council meeting. Are there any objections? Sorry, please. Do we have any objections? Nope. Okay. There are no objections, so we begin the work of the dissertation council meeting. The agenda includes the defense of the dissertation of Sadyk Ualikhan Sadyk on the topic a hybrid deep feature extraction traditional machine learning ensemble model for robust banknote recognition under various conditions in the educational program 8D06102 Computer Science. The work was carried out at the SD University and is presented in the form of dissertation work. The defense will be conducted in English. This is the first time the dissertation is being defended. We have official reviewers for this candidate, who is Professor Madina Mansurova. She's candidate of Physical and Mathematical Sciences, Associate Professor, Dean of the Faculty of Mechanics and Mathematics at Al-Farabi, Kazakh National University, and also Professor Alisher Skabylov, PhD, Acting Associate Professor, Department of Electronics and Astrophysics, Al-Farabi, Kazakh National University. The scientific consultants of our candidate are Professor Jimil Turan, PhD, Professor, Department of Computer Science at the University, and also Professor Hao Han Wang, PhD, Assistant Professor of School of Information Sciences, University of Illinois Urbana-Champaign, Illinois, USA. Are there any questions regarding the agenda? No questions? Okay. Then I request the approval of the agenda. Who is in favor of this agenda? Please raise your hands or approve. Okay. No objections, no abstentions. The agenda is unanimously approved by open vote. Then the speech is given to the academic secretary of the council meeting, Dana Utibayeva, to review the personal documents of the candidate, Sadyk Ualikhan Sadyk, and their compliance with the established requirements. Please.
Thank you. Good afternoon, dear colleagues, professors.
So I would like to briefly report on the documents submitted by the PhD candidate Ualikhan Sadyk for this dissertation defense. First of all, I would like to briefly outline Sadyk Ualikhan's academic background and research achievements. So Ualikhan Sadyk has completed a master's degree in computer science and has international research experience in the proposed research area. He has a total of 16 publications, including 8 publications in the journals included in the list of publications recommended for the relevant academic field, as well as 8 publications in the international journals indexed in Web of Science and Scopes databases. So the candidate has submitted all required documents, including the application reviews of the scientific advisors and department's positive recommendation, and the dissertation's abstract, dissertations itself, and the list of scientific publications. As I mentioned, the plagiarism verification certificate and educational documents, transcripts, as well as the documents approving the dissertation topic and scientific advisors' reviews. So the file also contains the ethics committee's conclusion and candidates' personal documents. All the required documents are complete, therefore we can proceed with the dissertation defense.
Are there any questions for the secretary of the PhD candidate regarding the personal file materials? No questions. Okay, wonderful. Thank you. Then the floor is given to the candidate for the presentation of the main points of the dissertation. Please proceed. Keep in mind 20 minutes is your
Good afternoon, distinguished members of the committee. My name is Ualikhan, and today I will be presenting my PhD dissertation work titled Hybrid Feature Extraction Traditional Machine Learning Ensemble Model for Robust Banknote Recognition under Various Conditions. This work was supervised by Associated Professor Jamil Turan at AZ University and Assistant Professor Hao Wang from University of Illinois Urbana-Champaign, serving as my external supervisor. I will start by grounding this research in a concrete national problem rather than an abstract benchmark. Kazakhstan withdrew 27.24 trillion tenge in cash across 232.5 million transactions in 2025 alone. And national payment system processed roughly 90% of the cashless turnover. So despite rapid digitalization, cash handling is still massive live financial activity. In plain terms, automatic banknote recognition is not a toy problem here. It has a direct economic relevance. The government has also declared 2026 the year of digitalization and AI, and this research aligns to UN Sustainable Development Goals covering AI-driven innovation, economic growth, productivity, and reduced inequalities. The core research problem breaks down into 3 technical challenges that any recognition system must overcome. The first one is inter-class variability. Same denomination can appear differently due to elimination, viewpoint, background, camera conditions, and physical conditions. The second one is inter-class similarity. And the next one is feature representation. So it means that there is a deeper representation challenge. No single type of image feature captures everything in a single classifier. The relevance of this work, this research is relevant on 4 fronts. Nationally, the tenge is still evolving. In 2023, a new Saka-style banknote series has been introduced, and there are 6 active denominations in circulation, creating an ongoing practical need for Kazakhstani denomination-specific recognition technology rather than one of tool. The practical relevance is, as previous slide showed, the cash remains heavily used despite digitalization. The third one is technologically, this work aligns directly with Kazakhstani national AI and digital transformation agenda, with 2026 officially declared the year of digitalization and AI. And scientifically, there is a genuine, verifiable gap in the literature. Zero public, annotated Kazakhstani banknote dataset existed before this work. And very little prior research addressed Kazakhstani banknote recognition specifically. Most existing work focuses on globally dominant currencies. Based on the research problems, three hypotheses guide the experimental design. The first one is hybrid representation, combining deep features extracted by ResNet 18 with handcrafted color features will improve banknote recognition performance compared using either feature type independently. The second one is ensemble learning. A stacking ensemble for complementary machine learning classifier will provide a robust banknote classification than individual-based classifiers. The last one, the proposed hybrid ensemble framework will maintain reliable performance even under variation in imaging conditions such as lighting or occlusion or other relevant conditions. The aim of this work to design, implement, and rigorously evaluate a hybrid recognition framework fusing ResNet 18 deep feature embedding with stacking ensemble for classical machine learning classifiers for accurate, for robust, lightweight, and computationally efficient Kazakh banknote recognition under unconstrained real-world conditions. In order to achieve this aim, we have defined 5 different objectives. The first one is to construct to open access Kazakhstani banknote dataset. The second one is design a hybrid deep feature extraction pipeline. The next objective is build and evaluate a model stacking ensemble using 5 different biases, machine learning models like KNN, SVC, RBF, random forest, Gaussian naive Bayes, and rich TV. The next objective is compare traditional and the hybrid machine learning approaches. And the last one is validate cross-domain transferability. The novelties of this research are twofold. The first one is a first hybrid Kazakhstani tenge banknote classifier. Development on the first lightweight hybrid machine learning classifier for Kazakhstani tenge, combining manual HSV histograms with ResNet 18 automated deep feature within a model stacking ensemble. The next one is dual open access dataset contribution. A literature review of this work, I have divided into 3 parts of the literature review banknote recognition methods. The first one is classical computer vision and the machine learning approaches, which was from 2009 till 2019. At that time, the highly accuracy only under controlled single nodes, fixed banknote conditions, and no data set published at that time. And those models not transferable to the Kazakhstani tenge. The second one is the era of deep learning and the CNNs. In 2022, Professor View has used MobileNet, fine-tuned, and achieved 98.3. Professor Talat has used VGG16 transformers and achieved 98% and 7. And other professors also achieved 95 plus.
We'll have some electricity outage, so it's starting up. So we'll proceed in a minute. Okay, please continue.
the second era was deep learning and CNNs. It was about from 2020 till 2022. And as I mentioned before, the several professors have used several approaches in order to achieve the high results. And according to the lit review, we see that most of the professors has achieved the 98% above. And but the problem is that nevertheless they achieved the higher accuracy, but the model getting heavier, and it's not lightweighted, and it's in terms of the computational cost, it's really large. The another era, the last one, is the transformers and my work. Also, the in 2023, with my students, we have tested the pre-trained model of the transformers. It's called VIT16, and as well as other CNN pre-trained models, ImageNet, ResNet 18, ResNet 50, ResNet 101. And we have seen that the vision transformers also was tested in our work, and the computational cost of this model was 4 times heavier than others. And that's why, as my core idea aim was to develop a lightweight model, we didn't consider this work as a benchmark. So the next one is a literature review of the banknote datasets, global landscape. Here I would like to show you that before this work, there was no public data set for the Kazakhstani tenge. When I was starting my PhD in 2022, I have I wrote an email to the central banks of the Kazakhstan, also for the Kazakhstan retail banks like Khalq and Kaspi, in order to get the data set from them of the banknotes. As you see that those banknotes, those data sets from the retail banks are private, and that's why I couldn't get them. And in order to achieve, make it possible, I have developed my own data set. In 2023, I have started to develop my own data set. The first data set was called KZBD data set, which was published in 2024. But nevertheless, I have started to collect my data when I started my PhD, and this data set contains 4,200 high-quality images. At that time, it was 14 denominations because of 8 coins and 6 banknote denominations, ranging from 1 KZT to 20,000 tenge. I have annotated them by using the YOLO bounding boxes by Label IMG program. Resolution of the images was 1.24 to 1.24 pixels, and it was split to training and validation data. As my core idea was to develop a lightweight model for the different conditions, I have developed a dataset from the different conditions like dark, illuminated, cluttered, occluded, and folded, damaged banknotes has been collected. And as well as my first dataset was uploaded to Mendeley Data and published it in Data in Brief journal, which is Q1, as well as in Scopus. The second dataset was called a new multi-scene dataset. Why I have started to collect the second dataset when I had the first one? Because in 2023, the Kazakhstan National Bank released a new denomination, which is called Saka style, and that's why I have started to collecting my another data set, which has only banknotes because we don't have changes in coins. Images, number of images is 1,846. There are 3 subsets like new single, new multi, and new mixed. Why I have used in order to make my experimental results, I have used 4 different evaluation metrics, and why I have chosen those 4. The first one is accuracy. Why I have chosen accuracy? Because it gives the overall fraction of the correct predictions. Use it as the primary benchmark of the compare against state-of-the-art methods on the same data set. The second one is the F1 score. The third one is Matthew correlation coefficient. It's considered the most informative single metric for multi-class classification, accounts for all 4 confusion matrix quadrants not misled by the class imbalance. And the last one is the ROC IUC. It's the also evaluation metrics for my work. This is my proposed methodology. Here I would like to explain about the network architecture of my work. The first step is the banknote image. So we give the banknote as an image to 124 to 244 in 3 dimensions. So example of the 5,000 tenge as a banknote. Then it goes through 2 parallel ways. I would say the first one is the ResNet 18. So I would like to note here that we don't train ResNet 18 end-to-end. We use ResNet 18 only for the deep feature extraction. So what is the deep feature extraction? It's the edges of the banknotes, lines of the banknotes, corners, textures, fine patterns, and other conditions of the banknotes. So here I would like here I gave the basic architecture of the ResNet 18, since we don't train the ResNet 18 as the end-to-end in order to classify the banknote. And then in the second part of my work, we take the color features of the banknotes. So in the first part, we take the D features of the banknote. In the second part, we take the color features of the banknote, RGB colors like hue, saturation, and value histograms as an output. In the first deep learning architecture, we take the 512 dimension vector. In the second one, we take the 768 dimension vector from HSV histograms. And then those 2 approaches were collected by the feature fusion, will be concentrated in feature fusion. Then we go through the hybrid feature vector. After that hybrid feature vector, we 5 different base classifiers like KNN, SVM, RBF, Gaussian naive Bayes, and the Ridge SV. Those 5 different independent models will give their own results. After that, we stack them, and then we use the stacking optimization and then get the final result as a classified banknote. So model stacking ensemble, how it works and why. As I already talked about, like 5 different classifiers like KNN, SVC, random forest, Gaussian naive Bayes, and RHTV. Those different classifiers will give their decision. Then we apply the meta-learner SVC in order to take the optimal weights combination of all 5 base classifiers. So this is how stacking ensemble works. So there might be the question why I have chosen exactly the stacking classifier, not other optimizers like boosting, bagging, Bayesian optimization, or deep fine-tuning. Because of the limitations, for example, the boosting has the high compute on 512 dimensional features. As I told you, in ResNet 18, we will take as a result the 512 dimension vector. The bagging is the single classifier family. The Bayesian optimization, it optimizes only the single models. In our case, we have 5 different models. That's why we have taken the stacking ensemble in order to optimize it and in order to get the final result. Results of the traditional machine learning approaches, we have divided it into before optimization and the after optimization. The first one is the before optimization. We have used 5 different classifiers like KNN, SVC, random forest, Gaussian naive Bayes, and RHTV. And before optimization, we have used only RGB color vectors. It's like 3 features, and we got the accuracy number for the SVC RBF. It was really highest, 71%. Then we have applied the optimization for that. Like in the second experiment, we take the only HSV histograms. It's like 768 features, and at that time we got the accuracy was 94.67%, with the model size is 10 megabytes. 5 megabytes. Then we stack them. After stacking, we get the accuracy 95%. At that time, we got the model size 10.9. This is the confusion matrix of the traditional approach. The rows means the actual denominations, the columns means predicted denominations. As you see in the pre-optimization, in the 71%, 1000 tenge misclassified as 2000 tenge. There are 25 errors, and vice versa, 10 errors, right? In the RGB, after pre-optimization, HSV 68 dimensional histogram separate color distribution precisely, and recital errors confined to 500 till 5000 tenge pair. Then the second part of my experimental results is the hybrid approach. It's like ResNet 18 and model size. Before optimization, I have trained only ResNet 18 plus other classifiers, and at that time I also got the accuracy which is highest in support vector SVC RBF with 97% 78. And after optimization, we optimized them by the grid search, and then we got results 99 plus 0.11%. Then we added the optimization for these models, stacking optimization for those models, and we reached the highest optimization, 99%, 99.55%. But I would like to take your attention for the model size. When I got the SVC RBF with the highest accuracy, 99.11, we got the model size 52. When we optimize them with the stacking ensemble, we reached the highest accuracy rather than the SVC RBF, but the model size slightly different, like from 52 megabytes to 52.97 megabytes. This is the confusion matrices of the hybrid and stacking ensemble models. So as before, the row numbers is the actual denomination numbers, the columns is predicted denomination numbers, and deep ResNet 18 features already separated denomination almost perfectly. Pre-tuning, grid search removes the recital confusion, and we achieved the highest accuracy of this work. Of course, this in the beginning of my work, I have given the 3 hypotheses, and this experiment gives the result of the second hypothesis. Then the cross-domain transferability validation. In order to make sure that my developed model works well in other denominations or in other domain, we have trained the same model, same dataset in other domains. Like the first one was my experiment. I have trained it in Kazakhstani tenge. The accuracy reached the highest 99.55%. In the traditional pipeline, it was 95%. The key insights of this work is ResNet 18 features cleanly separate all 6 Kazakhstani tenge denominations. Only one of diagonal entry in confusion matrix, model trained and validated on this domain. And the second one is the Thai banknotes. We have reached in the Thai banknotes 97.25%. In the hybrid pipeline, then in the traditional pipeline, it was 96.7%. And the last one is the coffee beans. It's totally different domain, not banknotes, but nevertheless, we would like to make sure that this works in the different domains. In the coffee bean roasting accuracy in hybrid pipeline, we have reached 99%. In the traditional pipeline, it was 100%. This is the confusion matrix of the cross-domain transferability.
2 minutes.
This is the comparison with state-of-the-art methods. It means that we didn't change anything. We applied the same dataset for those models. And as you see, the our stacking ensemble model with the ResNet 18 plus traditional machine learning models has reached 99% 55, the highest accuracy. Publication and research contributions. I have published 6 publications over this dissertation, the 4 of them in the journals, 2 of them Q1, 2 of them Q2, and 2 of them, the Scopus indexed conferences, and I have 1 preprint. We already submitted this work, and it's in review. It's in review process. Okay, as a conclusion, we have reached all hypotheses positively, and key findings of this work: hybrid ResNet 18 plus SVC RBF stacking achieves 99% 55 with 52.97 megabytes. It was the best accuracy across all experiments. The lightweight traditional stacking 95% at only 10.9 megabyte, smartphone deployable. 2 open access Kazakhstani dataset fill a complete benchmark gap. No prior public Kazakhstani dataset existed before. The methodology aligns with SDG 8, 9, 10, addressing financial autonomy of the persons in Kazakhstan. Then it's the cross-domain validation. It's the Thai banknotes. We achieved 97.25%. Then the coffee beans, it was from 99 till 100%. Broad transferability confirmed in this work. I would like to acknowledge SU University for supporting me, and then my research team is Associated Professor Jamil Turan, my external supervisor Hao-Han Wang, also other collaborators of my articles. Thank you.
Okay, thank you very much. So now we come to questions. So any questions? Who would to start? Yes, Professor Lindsay.
So thank you for your presentation. So actually, there is a few questions. Maybe there is like contradiction in your dissertation. For example, like in the first things when you mention in your introduction in your thesis, you mentioned that you have a hybrid method, and you mention only CNN and conventional machine learning algorithm. So
Sorry for your
okay,
question.
should I repeat?
Yes, please.
Okay. So you have mentioned actually in your thesis your novelty or the proposed method combine only 2 algorithms. And as I see in your presentation, you have mentioned a lot of algorithms that you have been used.
Yes.
So is it possible, like, just to summarize, where did you use each one of them and why you just mentioned 2 here? Why you didn't mention all of them?
Sure. So as I mentioned in my architecture, I have used ResNet 18. It's the CNN pre-trained model to CNN, not end-to-end. So it means that I didn't train CNN at all. It was used only for the D-feature extraction of the banknotes. Plus, I have used 5 different base learners of the classical machine learning model, which every machine learning model will did their own work and they give their own results. And I stacked them. So it means that I collected all the results in one way with the stacking ensemble. Stacking ensemble with the meta learner, stacking learned the weighted combinations of all base learners, then give the final result. This is the architecture of my work.
So your proposed method is not only 2. Your hybrid method is not just 2 algorithms, as you mentioned, and if you can change actually from CNN to ResNet, it will be much better because
from CNN ResNet.
Like here you just mentioned in your introduction, you just have only 2
because of the ResNet, it's the pre-trained model of the CNN. That's why I have mentioned CNN plus traditional machine learning models. And then in the experimental results, I have opened them. So I have given the detailed information that as a CNN, I have used ResNet 18 pre-trained model. As a traditional machine learning, I have used 5 different base learners.
So where did you use the YOLO algorithm?
YOLO algorithm has been used in bounding boxes. So when I prepared my data set, I cropped them. I cropped them with the help of the YOLO algorithm. The normally YOLO is so the how to say, the main purpose of the YOLO is object detection, not classification. That's why I have used YOLO algorithm in order to detect the objects in my banknotes in order to crop them.
Okay.
So if you go just to literature review, is it possible in slide of literature review? So in literature review, actually, you should mention previous study. I think there is no meaning to reference yourself to be as a reference. So this is literature review of your work. So you don't need to reference yourself as a reference.
Okay.
Isn't it? So you shouldn't just reference yourself.
Okay.
I guess the rest is okay.
Because of why I have mentioned my work here, I would like to explain. Because of maybe the committee member will ask why I haven't used the VAT16. This is the pre-trained model of the transformers. But back in 2023, we have trained all of them. I mean, like VAT16 and other pre-trained CNN models, and that's why I have mentioned my work here. But it's in order to prove that those algorithms are really heavier than the proposing one.
So another question, like, how did you get off overfitting? For example, you have some algorithm is 99.55, some of them 100%. So are you sure it's not overfitting?
Yeah, sure, I can answer for this question. The first, in order to prevent the overfitting, I have divided into train and test data. This is the first way to prevent the overfitting. Then we made sure that the train data was test data was trained only in unseen data. And another answer is we have trained 5 different base classifiers, machine learning models, right? Those machine learning models was trained differently. Those 5 machine learning models was trained independently of each other. And that's why all of them was combined to the stacking ensemble. And that's why therefore we prevent the overfitting.
So have you used L1, L2 for machine learning to get like rid of overfitting?
Yeah, we used meta learner.
Regularization for the
Yes,
dataset.
SPC RBF meta learner was applied in order to prevent the overfitting.
Okay, thank you.
Thank you.
Okay, thank you. Next, would like to ask questions? Yeah, please.
I have also several questions. First one is the area of use, practical applications. How can you explain the let's say importance of use?
Importance
why
of
is
this
it
work.
important?
So initially, when we started back in 2022, this work with my supervisor, our main goal was to develop a lightweight model which is deployable for the mobile application in order to help the visually impaired individuals to make them financially independent. This was our main goal. Then we didn't develop a mobile application. That's why we changed our goal to just to develop a lightweight model, as well as this work can be applied for the ATM machines, not only for the mobile applications for the visually impaired individuals. As the future work, we'd like to develop it for the Central Asian countries and expand it with the Central Asian currencies.
Next question then. Could you explain the reason of choosing specific models for your experiments?
Specific nodes?
Models, yeah.
So ResNet 18 So why I have chosen ResNet 18 as the deep-futuristic structure. So we know that we have lots of models, pre-trained models in CNNs like ImageNet, ResNet 50, ResNet 101. Why we have chosen this model? Because of it has 512 vector dimension as an output, and we need it. And the second one is to develop a lightweight model. The ResNet 18 was the light one among the other pre-trained CNN models. That's why we have chosen the ResNet 18 as a deep-futuristic structure. And why we have chosen those 5 different classifiers for the traditional machine learning model, it's because of all of them has the different biases, and that's why we have chosen more machine learning models in order to get the accurate result.
So next question, could you tell about the data set? How I understand, you have also images for coins, yeah?
Also has,
Could you say about the size of images, numbers of images for every class?
I can't exactly say the number of the images for the class, but it's balanced. It's totally balanced now. But in my work, we didn't consider coins. The main point of our work is to classify the banknotes. But initially, in my dataset, we have collected as well as coins as well as the banknotes.
And another question, could you open the page 16 about first graph, yeah? As we can see in the first line, yeah?
Yeah, we have errors.
In the cross of 2000 and 1000, we can see that the number of crosses are, I can see 25, yeah? How you can...
Over 2000 and 1000, it's 25, yes.
25, how you can explain it?
So this is the number of the errors. It means that the model confused 2000 with 1000 25 times.
And last question, what is the limitations or and also what future improvements do you offer?
So limitations of this work is it's the data set. I think that we have to improve the data set as well as to collect more data, because of we have every year, not every year, like in 2023, the new Saka style banknotes was released, but nowadays we don't have all of them novel. Like some of them already released, but we still have we're still waiting for the national bank releasing a new banknote. That's why I think that we have to develop a new data set for this work. And also, as a future work, I would like to add the cross-validation and collect the data of the counterfeit banknotes, which is fake banknotes, and adapt this work to classify the counterfeit banknotes as well.
Okay, yeah, please.
Thank you for your presentation. So I have several questions. So could we move to your dataset information? As you mentioned in your speech, your proposed novelties are to have 2 parts, one of them about your dataset. So on your dataset information, you are mentioning iPhone 11 on your first one, 2024's, second iPhone 15. What about other type of cameras? Because as we know, Apple products has good resolution on their cameras, even it's 11. So what about other brands? So you are taking your images from cell phone, yes?
Yes.
So do you think it's fit with the novelty when you are using only one type of camera on your dataset during gathering your dataset?
Oh,
so did you check on your test or during testing time with other type of cell phones except Apple products?
Okay. Back in 2022, when we collected this data set, I had only iPhone 11, and that's why the images was taken by me, like it was collected manually with iPhone 11, and the main aim of this work to develop a lightweight model which is deployable to the mobile applications. That's why we have used the mobile camera for this work, only mobile cameras. Your question was about like if iPhone 11 and if iPhone 15
Maybe
have,
Samsung, maybe other type of brands. What about?
I think
They don't have same resolution.
yeah, but it's not depends from the resolutions because of we are collecting data in different conditions like occluded, like cluttered, like folded, damaged banknotes in in the dark background, in the light backgrounds. The main of this work is to make the classification accurate in the different conditions.
Okay, I agree. So we should test it with only iPhone products or Apple products, you mean? So I agree with your lightweight other type of your proposing system, okay? But what about if we check new brands, other type of cameras, did you test your model?
Oh, I didn't test it in other type of the cameras, but as a future work, yes, we will consider it to expand our data set with the other cell phone cameras as well as test it in other cell phone.
Okay, thank you for your answer. So could we move to the model, stacking model?
Mhm.
So with the single layer and with the stacking, when you are using method of stacking, it might have some problems like overfitting. So what type of methods did you use during training your model to overfit, to avoid overfitting?
To avoid overfitting, I have already give the.
It's like repeating same layer. Stacking means, yeah.
Yes, we have the first one is we have divided the data into two, train and test. This is the first way we have prevented the overfitting. Then we made sure that the train data that the test data was trained in unseen data. It means that we didn't give the data which is trained to the test data. So that by this way we prevent the overfitting. Then the next step is we have used five different base classifiers as classification, like traditional machine learning models, and all of them will give their own results independently. Then all results was stacked with stacking ensemble, and we have applied meta-learnal SVC in order to get the weighted combinations as an output.
Okay, did you try to use layers like normalization or dropout, other type of layers at the end of your model structure? Usually we use L1, L2 normalization layers to avoid overfitting. So what about in your case?
In my case, we didn't train ResNet 18 end-to-end. So it means that we didn't classify with ResNet 18 this work. And that's why we didn't use the normalization.
So normalization, not batch, not other type. Okay.
I believe computer is still working, so there is no problem with online recording.
Yeah, computer still working.
So, okay, next question then. Yeah, I accept your answer. So what about your proposed models, model curves? So how did we trust or believe, or we can see if you are not overfitting or if you are not underfitting with the results 94, you are showing good results, but we are not seeing your model curves. So
yes.
Do you have?
In order to make sure that this model is working, we have used 4 different evaluation metrics. This is accuracy, F1 score, Matthew correlation coefficient, as well as ROC IUC. among those four models, when we use four different evaluation metrics for this work, and
So why we use usual confusion matrix? So in your case, you are providing
yes, also
confusion matrix. Why? What we can see from confusion
so in order
matrix?
to understand where our model is confused. Dağısın aşağı in, Science Department.
Okay. Go on.
Yes, I have showed the results of the confusion matrix in my presentation. As you see, yes, the model is not like 100% is not the 100% accurate. It has some errors, and I showed in the confusion matrix that in the first case, the 2000 tenge was confused by 1000 tenge 25 times. Yes, that's why we have confusion matrix in order to understand where our model is confusing.
So last question is about your balance imbalance data set you mentioned to the Professor Jandos. So you as we can see from confusion matrix, it's imbalanced. So you are mentioning general data set is balanced, but on your train test, they are not imbalanced?
Yes.
It's like that?
Yes.
Could you explain why it's like that?
It's the because of the coins, and in our first data set we have like 14 denominations, and we take only 6 denominations in order to train and test data. And when we divide it as a 75 to 25, like train and test data, yes, it causes like the data was imbalanced as a result.
So, but you have enough data set. Why you decided to make it as imbalanced in your test version?
Yeah, it was not like from outside, like when
So did you try like not through the mathematical part, you tried to use on the base of experimental works, yeah?
yes.
So you decided on the base of your experimental works?
Yes, we didn't like optimize them via mathematically. Yeah, we made the optimization via coding way, like optimizing the architecture.
Okay, no questions.
Okay, thank you.
Maybe
Maybe other questions? Yeah. Yes.
Рұқсат болса, қазақша сұрақ қойсам.
Жақсы.
Алғашқы сұрақ, сіз өзіңіздің жұмысыңызды YOLO деген модельмен салыстырып көрдіңіз бе? YOLO-ның
YOLO
классификациясы.
деген, мен ағылшынша жауап берсем бола ма? Yes, let me show you the results of the YOLO versions. Yes, here. This is the results of the YOLO versions. We have trained our data in YOLO version 8, and as you see, the accuracy is really high, 98.2, but the model size is 136 megabytes. But we considered YOLO versions, but it's more than heavier than our work.
Рахмет. YOLO-ның 8 емес, 11, 26 деген версияларын қарастырмаңыз ба?
No, I didn't consider them.
Датасетқа қатысты сұрақ. Сізде датасетіңізде айтылған екі түрлі датасет туралы. Енді осы жерде блокноттар распознавание жасаған кезде әрбір суретке бір блокнотадан түсірілді ме, әлде бірнеше блокнота бір фотода болды ма?
Okay. In the first data set, it was like that, one banknote per frame. But in the second one, as you see, we have the new single, new multi, and old multi. It means that like multiple denomination in the one frame. So we did consider the banknotes per frame and the multiple banknotes per frame.
Ал бір суретте бірнеше блокноттар болса, ол задача қалай шешілетін еді?
Yes, the results shows it's 99%, 99.55%, because of, as I mentioned before, in the second data set, we have added several denominations in one frame, and that's why it shows it works well.
Келесі сұрақ. Сізде камерамен түсірдіңіз өзіңіздің iPhone
Yes.
телефонмен. Енді осы телефон қандай қашықтықта болу керек? Қандай ара қашықтықта распознаваниеңіз жақсы болу үшін?
I didn't check it, but we when we collecting the data, it doesn't depend from the расстояние. Yeah, from the distance. The main problem was to develop under various conditions, like as I mentioned before, the dark background, illuminated background, occluded, damaged images, or the occluded in your pocket.
Жақсы, рахмет. Сұрақ жоқ.
Thanks. Maybe some members of the council from online, Professor Levashenko, have questions?
Hello. I have no special questions. I would like only recommendation. Maybe it will be perspective to use explainable artificial intelligence for describing obtained results.
Explainable.
For example, method
Professor-
lines and etc. It's only idea for future investigations, for future researchers.
Yes, thank you. Thank you. We will consider your recommendations.
Okay, thank you.
Thank you.
Okay, maybe the next member, Oldragas, Professor.
Yes, thank you for your presentation. I have several questions. The first question is, we can see that traditional approach also achieved strong results after introducing HSV histogram features. In what situations would you recommend using the traditional approach instead of the hybrid approach?
So the question was about traditional machine learning already gave the highest accuracy, right?
No, after
And-
introducing HSV histogram features, it also showed higher, better, strong results. And in what situations would you recommend using traditional approach instead of the hybrid approach?
When we have the hybrid approach, we really have the highest accuracy. It's like 99.55, comparing to traditional machine learning approach, 95%. And I think that it depends on the accuracy, how accurate your accurate model you want. You have to use them. As I mentioned in my presentation, we have reached 99.55 in the hybrid approach, and that's why it's better to use that method rather than the traditional machine learning method.
I mean, model size is much less than hybrid approach, I guess.
The
Next question, yeah.
Okay.
Yeah, next question, I will come this. You use 200 images per class for the traditional pipeline, yes, and 150 images for the hybrid pipeline.
Yes.
How do you justify the conclusion that the ResNet 18 representation is actually better if both methods are not tested on the same data? Do you think the results will change if you compare the two models again on the same 150 images?
Mm-hmm. Could you elaborate your question, please?
Yeah, you use 200 images per class for the traditional pipeline and 150 images for hybrid pipeline. How do you justify the conclusion that the ResNet 18 representation is actually better if both methods are not tested on the same data, different size of test data?
Professor, could you tell me which page should I go, please?
I mean, I'm
images,
asking from your
150.
dissertation thesis.
Okay.
Yeah.
So thank you for your questions. Yes, you're true that we have used 200 images as a traditional machine learning method and the 150 for the test for the hybrid method. Yes, that's correct. But the question was about like how you. Could you please elaborate your question? Sorry.
Do you
I really
think
lost
the
my mind.
results? Yeah, do you think the results will change if you compare the two models again on the same 150 images?
Yes, but right now I can't tell the result. But as a future work, yes, we will consider your recommendation and we'll fix it.
Okay. The hybrid model provides high accuracy, yes, but requires a larger model size. How would you
Yes.
balance recognition accuracy and computational efficiency in a real-world application, real-world system?
Yeah, we as you see in my results, we optimized our ResNet 18 with grid search. So it means that could you elaborate your question, please?
Can you see just can you show a page where
Can you say it in simple way, please?
Simple.
Could you just show me the page where you showed results with model size? There was one presentation.
That one.
Yeah. For
This
example,
one?
here, yeah, SVC, RBF, and stacking almost like the same accuracy, like 99%, but different model size. In real world application, how you balance recognition accuracy and computational efficiency in real world system? Real-time application.
Yeah, since we didn't apply this model for the mobile deployment yet, yeah, we can consider it as a future work.
Okay, you evaluated the methodology not only Kazakh banknotes, but also on Thai banknotes and coffee bean images. What did these additional experiments reveal about the applicability of your proposed approach? What's the reason to use this extra additional?
So the reason is to check the transferability of this model in different domains, rather than banknote denominations also in different data sets.
Okay. I have no questions.
Thank you very much. So I just have short question. Have you researched what are currently algorithms used in our ATM machines?
No, I didn't.
So maybe you can propose your own version.
Because of they're in the ATM machine, they're using embedding systems like hardware, not the software. And
your model is very small, so maybe it can fit in their IoT solution.
Yes, yeah, we can consider it as a future work.
Okay. Thank you very much. If we don't have any questions, we can proceed with the next stage. Wow, okay, that's good. Where we are. So now we go to the our supervisors, I believe. Okay, the speech is given to the domestic scientific advisor, Professor Cemil Turan. Please, your speech can be short. Please turn on.
I think Ualikhan is just have done a good job, according to me, actually, and he is ready for his finishing PhD process. Long time after 4 years, right?
4 years.
Yeah, this is a 4-year work. So mostly, sometimes we work together, not all time, but Ualikhan has effectively worked on it. He develops some methods, compare them, even just not only Kazakh banknote recognition, even test his methods in another recognition area just test his methodology effective or not. So after all, just I congratulate him for the end.
Okay, thank you very much. So the next is the speech from foreign scientific advisor, but he's not present. So I'll give the floor for our consul secretary to
So
address.
thank you. I have review report from the Professor Hao Huang. He works in a School of Information Sciences, University of Illinois Urbana-Champaign. So he's giving. I would like to read it briefly. So he's giving his review. The review is given to the PhD dissertation entitled A Hybrid Future Extraction Traditional Machine Learning Ensemble Model for Robust Banknote Recognition Under Various Conditions, submitted by Ualikhan Sadyk under the major 8D06102 Computer Science. So he's considering his dissertation a well-founded hybrid recognition framework that employs a pre-trained ResNet-18 convolutional neural network as a deep future extractor and combines it with an ensemble of traditional machine learning classifiers. So he thinks the author convincingly demonstrates using deep neural networks. So here he's mentioning about datasets. A notable contribution of dissertation is the development and utilization of Kazakh banknote dataset, KZBD, and Kazakh banknote image dataset. Also, he thinks his dissertation is well structured, logically organized, and supported by the comprehensive review of relevant international literature. The research results have been validated through peer-reviewed publications, confirming their reliability and scientific significance with these publications. So overall, the work of Ualikhan demonstrated his ability to conduct independent research at high academic level and provides meaningful theoretical and practical contributions to the field of computer vision, CV, and machine learning. So he thinks dissertation fully meets the requirements for the PhD degree, and he is recommending for the public defense.
Thank you very much. So it seems like we move to the next stage, the discussion. And now I give the speech to the official reviewers. The first is Madina Mansurova, candidate of Physics and Mathematical Sciences. Please.
Dear colleagues, thank you for this presentation, and let me share shortly my review. First of all, this dissertation topic aligns with the priority direction of information communication and space technology approved by the High Scientific and Technical Commission of our country. Related to significance for science, I can say that about the theoretical significance, this work shows that the frozen ResNet-18 encoder plus a staked classical ensemble guarantee an accurate computational economical decision layer. And from the practical significance, we see that the OSA developed the open Kazakhstani banknote dataset and the lightweight deployment-ready model. Related to the principle of self-writing, dataset construction, preprocessing, embedding, extraction, and other steps were carried out personally by the author and confirmed by his papers in journals and in proceedings. Related to the principle of internal unity, the author identifies a concrete gap in public benchmark and robust recognition methods, and this work help to improve the level of financial digitalization and assist technology. Related to the structure of this work, the goal and 6 objectives are consistent and addressed sequentially from dataset construction to embedded deployment efficiency. The main important part related to scientific results, and we see that the proposed hybrid ResNet 18 plus stacked ensemble pipeline for regional currency recognition, not previously addressed for the tenge. And the one more result, it is the data set created by the OSA. The main conclusions are supported by the substantial experimental basis and including more than 4,000 images. And we see that the experimental evidence is sufficient to support the principal conclusions of the dissertation. And I want to say that the level of this work is very high. The key statements are supported by references to verifiable scientific literature. In this dissertation, we see the 83 sources for the valuable papers, and the theoretical significance lies in advancing hybrid computer vision methodology, showing the discriminative power of frozen encoder paired with classical ensemble learning for regional currency recognition. Dissertation notes and the recommendation. Although the experimental results are strong, the statistical robustness of the comparative evaluation could be further straightened. The traditional and hybrid pipelines were evaluated using different sample sizes, and the principal classifier results are based on a fixed train test split. In further studies, it will be advisable to report confidence intervals, repeat experiments across multiple random seeds, and apply group-aware splitting to ensure that images of the same physical banknote cannot occur in both training and test sets. This recommendation does not affect the validity of the presented results, but will further strengthen the evidence for generalization to previously unseen banknotes. In the second, it is recommended to further harmonize the description of the experimental protocol across the dissertation. In particular, the description of data augmentation should clearly distinguish between the general methodological framework and the classifier comparison experiments reported in Chapter 3. The above comments are methodological and recommendatory in nature. They identify directions for further strengthening the statistical validation and reproducibility of the proposed approach, and don't diminish the scientific novelty, validity of the main results, theoretical significance, or practical value of the dissertation. And let me share the conclusion. The dissertation of Sadyk Ualikhan Sadyk, entitled A Hybrid Deep Feature Extraction Traditional Machine Learning Ensemble Model for Robust Banknote Recognition Under Various Conditions, represents a completed and independent scientific study. The obtained results possess scientific novelty, theoretical significance, and practical value, and the main conclusions are supported by the presented experimental evidence. The dissertations meet the established requirements for doctoral dissertations, and its author, Sadyk Ualikhan Sadyk, deserves to the awarded the degree of Doctor of Philosophy PhD in the specialty 8D 06102 Computer Science. Thank you so much
Thank you,
for your
Madina.
attention.
Thank you. So now we'll give a floor for the candidate to answer to the comments which were mentioned by our reviewer.
Yes, we have worked with Madina Yasimkhanna throughout this last 1 month when she was my official reviewer, and yeah, I agree with all the comments of the Madina Muhammad, and we will fix it as a future work of this dissertation.
Okay. Thank you. Thank you very much. So we go to the next speaker, second official review, Alisher Skabul, PhD Action Associate Professor at HIMSS.
Thank you, dear members of Dissertation Council, dear colleagues. It's a pleasure to be here today, and I would also like to briefly present my review. First criteria, correspondence of the dissertation topic to the priority area of science. The dissertation corresponds to the priority area information communication and space technologies approved by the Higher Scientific and Technical Commission of the Republic of Kazakhstan. The research focuses on computer vision, deep learning, and automatic recognition of Kazakh banknotes under real-world conditions. The topic is particularly relevant because it addresses the application of artificial intelligence to a practical problem related to financial technologies and digital transformation. Second, significance of the work for science. In my opinion, the scientific significance of the dissertation is high. The author addressed an important problem, reliable recognition of Kazakh banknotes when images are captured under different lighting conditions, viewing angles, background, partial occlusion, and physical way. The proposed solution combines deep feature extraction using ResNet 18 with classical machine learning classifier in stacking ensemble. Independence of research. The dissertation represents an independently conducted research short after completed the main research stages himself, development and annotation of the dataset, preprocessing of the images, extraction of deep features, development and optimization of machine learning models, construction of the stacking ensemble, and experimental evaluation. Six criteria, validity of the main conclusions. The main conclusions are supported by a substantial experimental basis. The dataset KZBD dataset contains 4,200 annotated images, and the experiment used several evaluation metrics, including accuracy, macro F1, MCC, and ROC AUC. The author also performed comparative and ablation experiment to determine how much each component contributes to the result. The final hybrid staking configuration demonstrates the highest recognition performance among the evaluation approaches. Importantly, the author also analyzed the computational cost of the proposed solution rather than focusing only on recognition accuracy. Main principle proposed for difference criteria 7 in my assessment. The main principle proposed for defense are experimentally supported, non-trivial, and scientifically relevant. The research demonstrates the effectiveness of combining the future representation with classical machine learning models and ensemble learning. 8 criteria. The methodological is clearly defined and appropriate for the research objective. The study follows an experimental and quantitative design. The main pipeline includes image preprocessing, ResNet 18, feature extraction, classical machine learning classification, staking, and comparative evaluation. 5 classical classifiers are used in the study: KNN, CVS, random forest, Gaussian knife Bayes, and range. Their parameters are optimized, and their outputs are subsequently combined through staking. And also the scientific statement are supported by relevant literature, and the dissertation contains 83 references, including scientific 6 publications in the Scopes database, and 9 criteria, theoretical and practical significance. The dissertation has both theoretical and practical significance. From the theoretical perspective, it contributes to the development of hybrid computer vision and machine learning approaches. From the practical perspective, the proposed methodology can be applied in financial infrastructure, mobile application, and assistive technologies, particularly for visual impaired users. 10 criteria: quality of academic writing and presentation. The structure is logical. The methodology is described sufficiently, and the experiment result and conclusions are presented consistently. And so comment and recommendation. I didn't identify any significant scientific or methodological shortcomings that would affect the quality of the dissertation. There are only minor editorial and presentation related issues which can be addressed during the final revision. These comments are recommendatory and don't reduce the scientific value or practical significance of the work. And the conclusion, in conclusion, I consider the dissertation of Sadyk Ualikhan Erkinoğlu to be a complete, relevant, and independently conducted scientifically study. The research presents a clear scientific contribution. The main conclusions are supported by experimental evidence, and the work has both theoretical and practical significance. Therefore, I give a positive assessment of the dissertation and consider that Sadyk Ualikhan should be awarded the degree of Doctor of Philosophy in the educational program 806102 Computer Science. Thank you.
Thank you very much. Yeah, maybe candidate would like to answer to the comments.
The first of all, I would like to say thank you for Ilker Aliyoğlu because of his continuously support during my review of this work as an official reviewer, as well as to the Madina Ismhamna. Thank you.
Okay. There was. Yeah. So we finished with reviewers. Maybe some other members would like to. So we move to the discussion, make some speech. They do some follow-up questions or share their own impressions. Anyone? So let me start then. Okay. So I have been listening to his presentation, also to the question and answers. We see that that work was done very thorough, and it's also impressive that there is no such collection of data set in Kazakhstan for Kazakh language, Kazakh banknotes. It's nice to have someone starting that. That's good. And we see that there is multiple areas where he worked on the data set collection. They train one of the algorithms and other algorithms. And so presenting all of that in one dissertation, so I believe would be very nice. And so I would encourage to support him. Thanks. Maybe others?
I would like to add some recommendations. So in the future, please try to use another type of cameras with another type of resolutions. Also try to test in real life. And try to use its computational space and time. And so.
Okay, thank you. Any others would like to express their own opinions? After evaluation. Okay. So now this part is actually for the evaluation, so that we can a little bit know what is general mood here. Okay. And yeah, if maybe online presenters, yeah, please, Madina, if you would like to.
Yes, I provided the official my review, and I want to say that I know Ualikhan long time. He is very with a high responsibility person. He advanced not only in research area but in educational area, and now we see the very perspective work, because this pipeline and this model you can offer for other currencies, you can use for other currencies, you can offer for our Central Asia partners, and I see that the work is focused on computer vision. And as colleagues offer, he can continue the experience with different cameras, different conditions. It is not in future. This work can be used not only for currencies, for banknotes, but for other areas related in fintech sphere. And from the question answering session, we saw that the candidate is has a high professional level. He heard the questions, react fast, and he is competitive in this area. So I support this work, and I wish the new proposals, new projects, and please continue this work, and please get the more higher results. Thank you.
Thank you. Okay. We don't have anyone to speak. Then we can conclude on that. We have one more question to decide. According to the regulation, we now proceed to the secret voting procedure. To conduct this procedure, we need to elect the counting commission. So we would like to propose some from the hybrid members from, for example, if we ask Jandos Dosbaev to be head of this commission and ask Professor Alandi and also the Professor Daurin, would you like to be, so the commission for accounting. So we'll give you numbers, you announce and fill the document, okay? Thank you. If we have, so agree on that, do we need to vote for that? So we need to vote. Is it okay for these three members?
Yeah.
Yes? Okay, thank you very much. All are in favor. Then counting commission has been elected. I asked the counting commission to proceed with the work. Now we announce a break for the voting. Okay, so everyone, please, please pause the recording.
Geldim abi. Yağmur. Yaşası bir başın geldim.
Yes, I'm waiting reference.
Yazбаған екен.
Professor Ivashenko, are you there?
Yes, I'm here.
So I'm setting new link for the attendance, online attendance, I mean. So could you sign it there also?
Yeah.
New link I'm sending, not to mix with the previous one. I'm sending newly here.
This is just a requirement for the ministry that we have all attended and we are present here. Yeah, okay. Just
Yes. I'm sent my answer. I would like to support.
yeah, the first is answer. The second is just a presence sheet. Can you also feel that?
Okay, I check it, Jane.
I have sent already.
Please check. Yeah.
Your response has been recorded. I can read. Your response has been recorded. Форму можно отправить только один раз. Okay. I do it, Jane.
I believe we can start the recording. Yeah. Okay, recording started. Okay. So we resume the work of the dissertation council, and to announce the results of the secret voting, the floor is given to the chairperson of the counting commission, Dr. Jandos Dosbaev, please.
Компьютерлік ғылымдар мамандығы бойынша философия доктор дәрежесін алу үшін a hybrid deep feature extraction traditional machine learning ensemble model for robust banknote recognition under various conditions тақырыбында диссертация қорғау бойынша жасырын дауыс беру нәтижелерін шығару үшін тағайындалып, кеңес мәжілісіне 7 кеңес мүшесі, оның ішінде қаралып отырған тақырып диссертация саласы боюнча 3 ғылым докторы, ғылым кандидаты, PhD қатысқандығын баяндай, және жасырын дауыс беруге 2 ресми рецензенттер қатысты. Жасырын дауыс беру электронды форматта өткізіліп, толтырылған электронды бюллетендердің саны 9 болды, жарамсыз бюллетендердің саны 0. Дауыс беру нәтижесіне тоқталатын болсақ, философия докторы PhD немесе бейіні бойынша ғылыми дәрежесін беру үшін 9 дауыс, диссертацияны пысықтауға жіберу 0 дауыс, яғни диссертацияны қайта қорғауға жіберу 0 дауыс, және философия докторы PhD немесе бейіні бойынша докторы ғылыми дәрежесін беруден бас тарту үшін 0 дауыс берілгендігін жариялады.
So you see nine votes in the favor. So who is in favor of approving this protocol for the counting commission? Okay, all in favor. So now the procedure is like this. Now we have the protocol approved. The dissertation council for the education program 8D06102 Computer Science at SD University, based on the public defense of the dissertation of Ualikhan Sadyk Yerkanullah on the topic a hybrid deep feature extraction traditional machine learning ensemble model for robust banknote recognition under various conditions, has decided to petition the committee for the awarding of the degree of Doctor of Philosophy, PhD, or Doctor of Science in the profile. So we're going to petition for the awardings. Thank you. Now, candidate, you have a floor for final remarks.
Yes, the first of all, I would like to thank you to everyone who made it possible during my journey, supported, namely, yes, of course, I would like to say, dedicate this work for my mother who passed away 1 year ago, as well as my wife and other supporters. Thank you.
Thank you very much. So, meeting of dissertation course is concluded. Thank you very much. That's it. Thank you.
Okay, thank you.